Today, we're diving into a piece of technology that was literally forged in the heat of aerial combat, but is now showing up in the car you might drive every single day. We are talking about the incredible, game-changing head-up display.
Okay, I want you to just picture this for a second. You're a pilot, you're in charge of a multi-million-dollar jet, and your job landed on this tiny little strip of steel that's pitching and rolling in the middle of the ocean. The margin for error here is, well, it's zero. It is one of the most demanding things you could ever ask a person to do.
So in those last few critical seconds, you just don't have time to glance down at your airspeed, check your altitude, and then look back up and try to refocus on the carrier deck. I mean, taking your eyes off that target for even a split second could be a total disaster. So you have to ask, how is this even possible?
Well, they do it by using a piece of tech that completely changed aviation forever, the head-up display, or what everybody calls the HUD. It's a really simple name for a system that solved one of the most basic, fundamental problems in flying. So what exactly is a HUD? To really get why it's so brilliant, we first have to understand the problem it was designed to fix, the simple but incredibly dangerous act of just looking down. The whole idea is right there in the name. A head-up display is basically a see-through screen that projects critical info directly into your line of sight. The entire goal is to keep your head up and your eyes looking out at the world, which massively cuts down on the mental work of constantly shifting your focus. And this comparison just nails the difference. On the left, you've got the old head-down world. The pilot's attention is totally split, right? Constantly jumping between the instruments inside and the world outside. But on the right, you have the head-up solution. Airspeed, altitude, heading, it's all floating there, laid right on top of the real world. No more split attention, no refocusing your eyes, just pure instant information, saving those precious milliseconds that really matter.
So, where did this amazing breakthrough come from? Well, like so many incredible inventions, from radar to GPS, the HUD was forged in the heat of combat. It was born out of pure necessity during wartime.
And the technology grew up fast. It all started with these simple reflector gun sights before World War II. But the first really big leap forward came in the 1940s, when the Royal Air Force started projecting radar data into their night fighter sights. Then, in 1958, the first true HUD showed up on the Royal Navy's Buccaneer jet, mixing flight data with a bomb sight. From there, the tech jumped to commercial airlines in the 70s, and then get this. In 1988, it finally landed in the consumer world with the Oldsmobile Cutlass Supreme. All of this sounds a bit like science fiction, doesn't it? Just data floating in midair. But it's not magic. It's actually a really brilliant combination of computers and some very clever optics. So let's break down exactly how it works. A modern HUD really boils down to three key parts. First, you've got a computer, and its job is to create all the visual symbols using data from the aircraft's systems. Second, a projector takes that digital image and beams it forward. And third, the combiner. Now this is the special piece of angled glass that reflects that projected image back to the pilot's eyes, while still letting them see straight through it to the world outside. And here, you can actually see that whole system in a real cockpit. That box on the dashboard, that's the projector unit. And that angled piece of glass right in front of the windscreen, that is the combiner. It's just a beautifully elegant piece of engineering. Now, the secret sauce that makes all of this work is a concept called collimation. The projector uses special lenses to make all the light rays in the image parallel. This basically tricks your brain into seeing the image as if it's infinitely far away, on the exact same focal plane as the horizon. So, and this is the crucial part, your eyes don't have to refocus between the HUD symbols and the horizon. It solves that whole focal depth problem, which is what makes the system so incredibly effective. So, what kind of information is actually useful to see floating out there in your field of view? Well, the data that gets displayed is tailored precisely to the mission, whether that's landing on an aircraft carrier or, just driving to the grocery store. In a military setting, a pilot is trying to process a massive amount of information all at once. You've got airspeed, altitude, G-forces, and of course critical weapons and targeting data, all presented in a way that lets you make split-second decisions. So let's break down some of the most vital info. The display shows the pilot not just where the plane's nose is pointing, but more importantly, where the plane is actually going, after you account for stuff like wind and gravity. It also shows critical data for avoiding stalls and has indicators that lock right onto targets. And this slide, wow, this slide really shows the technology's incredible journey. On the left, you have this super data-rich display of a fighter jet designed for life-or-death combat. And on the right, That same fundamental idea, giving you vital information head up, has been perfectly adapted for the road. The BMW HUD shows your speed, the speed limit, and your next turn, all designed to keep your eyes on the road ahead. This whole evolution brings us right to the present day and to the future. Because the HUD isn't just a display technology, it's basically the grandfather of a concept that is about to change how we interact with, well, pretty much everything: augmented reality. Let's be perfectly clear about this. Head-up displays are the first widespread form of augmented reality. I mean, for over 60 years, they have been successfully overlaying digital information onto our view of the real world. They solved fundamental AR problems like focal depth and user interface design long before we even came up with the term AR. So the first step in truly augmenting our vision was the Enhanced Vision System, or EVS. This takes things way beyond just symbols. It uses an infrared camera to project a real-time thermal image of the world onto the HUD. So now the pilot isn't just seeing data, they're seeing the real world enhanced, literally seeing through the fog and rain to the runway lights beyond. And the next generation builds on this: synthetic vision systems, or SVS. Instead of just enhancing the real world, an SVS creates a complete 3D digital twin of it. Using a high-res terrain database and GPS, it generates a virtual world that lines up perfectly with the real one, creating this tunnel in the sky for the pilot to follow, no matter how bad the visibility outside is. And the technology just keeps pushing boundaries. Israel's Iron Vision system puts this tech inside a tank. Cameras mounted on the outside project a seamless 360-degree view onto the crew's helmet displays. And just as the source material says, this lets them stay buttoned up, completely protected inside, while having perfect situational awareness. It's basically a see-through tank.
So, from a simple glowing circle in a gun sight to a fully synthetic world, HUD technology has fundamentally changed how we interact with our environment. It's made us safer, faster, and way more capable. The real question now is, with this incredible power to overlay a digital layer on our reality, where do we go from here?